Types of sand dunes. Barchan dunes. These are crescent shaped dunes with horns pointing downwards. They formed in the areas with less sand availability and persistent wind direction, that is unidirectional in nature. Wind gathers small amounts of sand on the hard desert floors. Constant wind from one direction drives sand into a crescent shape. A rock or a vegetation slows the wind, causing the sand to accumulate. Sand climbs gently up the windward side and the sand cascades down the leeward side, forming a slip face. Lighter sand at the edge is pushed further, creating the horns. The dunes migrate slowly in the wind direction as the sand is recycled at the crest. The windward side, having gentle slope, is a convex plane, while the leeward side is a concave in plane with steep slope. The crest of the Barchan is divided into two horns downward due to prominent prevailing winds, wind eddies and limited supply of sand. It may be pointed out that the mechanism of the formation of the two horns of Barchan is not properly understood. Wind eddies transform the leeward slope into a concave element and remove the sand from the middle portion and deposit them along the sides. These horns are sharpened and extend downward by the prevailing wind, and thus crested shape of the Barchans is developed. Isolated Barchans migrate freely across the desert plains. In fact, Barchans are large enough to maintain themselves as they migrate and represent a remarkably balance between accumulation, transportation and erosion, given by A. Bloom. Sevenhaden has observed 3 cases of the migration of active Barchans. Barchans regularly with constant rate when the sand supply is constant. They advance with decelerating rate when the sand supply goes on increasing, but the height continues to increase. They advance with accelerated rate when the sand supply continues to increase. Regular advancement or migration of Barchans result in gradual spread of the desert. Sand-free corridors or gassi between two ranges of Barchans are used as caravan routes. The height, average length and width in the Thar desert are 2 to 15 meters, 150 meters and 250 meters respectively. Transverse dunes. Long ridges of sand perpendicular to the prevailing wind. They are generally seen in the areas with abundant sand and constant or unidirectional wind. Abundant and accumulates in large volumes. Unidirectional wind pushes sand into linear ridges. They form into a continuous ridge due to overlapping of Barchans. Each ridge has a gentle windward slope and steep slip face. Ridges extend sideways due to continuous deposition. They appear as a wave feature. The height of the transverse dune in the Thar desert of India is 3 to 25 meters, while the length and the width are up to 750 meters and 150 meters respectively. Longitudinal dunes. These are narrow, long ridges parallel to the dominant wind direction. They are also called as surf dunes. It is an Arabic word meaning sword. When the wind blows obliquely or form alternating directions, wind arranges sand along a line, not across. Windward side gets eroded slightly, leeward receives depositions. Ridge glows long, can be 100 kilometers, but remain narrow 100 to 1 kilometers width. Both the sides or often the dune may have slip faces due to shifting of the dune. These dunes are formed in the inner parts of the great desert where high velocity of winds are constant in direction or they change their directions seasonally. Great systems of longitudinal sand dunes are found in Australian, Libyan, Saharan, South Africa and Thar desert. Longitudinal dunes are almost parallel to each other and they are separated by sand-free bare surfaces known as reg or hamada. Such sand-free corridors between The parallel dunes are called as gassy or Sahara. Such corridors in the desert are used as a paths known as caravans. Such dunes are also called linear dunes, sand ridges, shelves, alab dunes, etc. Parabolic dune. They are U-shaped dunes with horns pointing upward. They are opposite to the birchen. They are generally observed in areas with some vegetation in coastal deserts and semi-arid areas. Vegetation anchors the sides of the horns. Wind blows out the central part, moving it forward. The arms or the horns stay fixed due to the roots, faces upwind. Middle portion moves faster than the horn, increasing the dune height. These dunes are much longer and narrower than birchens, but are always associated with blowouts. Star dunes. Pyramidal dunes with multiple arms or ridges extending from a central peak, found where winds blow from multiple directions. Several wind directions meet at a point. Sand is deposited in different arms or lobes. Vertical growth is more than the lateral spread. The dune grows upward in the place rather than moving. Dome dunes. Low, rounded, elliptical dunes with no particular slip face. It occurs in low wind or multi-directional wind zones with moderate sand. When wind velocity is too low for the steep slip faces, sand falls evenly, forming dome shape. Dome dunes are usually stationary. Other forms of the dunes. Dunes have intermediate characteristics between star dune and transverse dune are called as reversing dune, which are formed when wind blows from opposite direction, are balanced in the strength and the duration. The dunes formed of coarser sands left behind due to migration of the longitudinal dunes are called as whalebacks or whaleback dunes. Very large whalebacks dunes are called as drass. They are characteristic feature of Saharan and Namibian desert. They generally appear in compound or complex dunes. Loess. Loess is a fine-grained wind depositional landforms primarily composed of silt-sized quartz particles, often contains mix of clay and carbonates. It forms an extensive blanket like deposits over large areas and plays a major role in soil fertility and geomorphology process. The term loess comes from a German word loess, meaning loose or crumbly. First studied in Rhine Valley of Germany in the 19th century by Carl Sizevan Leonhard. These depositional landforms generally occur at far places from the source area. The source area can be a desert area, floodplains of a river valley, coastal areas and glacial outwash plains. Key characteristics of loess. These are fine-grained silt and clay, porous and loosely compacted, typically yellowish brown or buff colored. Composed of minerals like quartz, which is mainly feldspar, mica, calcite and other minerals. They are unstratified, homogeneous, ranging from few centimeters to over 300 meters. They are highly porous and permeable, but it is very prone to erosion.